Bismillahirrahmanirrahim. Assalamu alaikum. Dear all, I am Hassan Zada and today we will discuss lecture number 4 of data analysis in SPSS. Lecture number 4 is correlation analysis and problem of multicollinearity. In previous weeks, we have discussed 3 lectures. Lecture number 1 was about data entry in SPSS. Lecture number 2 was about descriptive statistics and frequency distribution. Lecture number 3 was about checking reliability of a scale and treatment of reverse coded question. Today we will discuss lecture number 4, that is correlation analysis and problem of multicollinearity. So first of all, what is mean by correlation? Correlation means the relationship between two variables. Correlation tells us about two things. One is the linear relationship between variable and the second is strength of the relationship. So what is linear relationship between variables? It means that what is the relationship between variables? The relationship can be positive and the relationship can be negative. Positive relationship is when one variable increase and due to increase in one variable the other variable also increase. Both of these two variables move in the same direction. This is called positive relationship. Similarly, when one variable decrease and the other variable also decrease, it is also a positive relationship because the direction of change of both of the variable are same. Here there is upward movement between two variables and here there is downward movement of the two variables. Both of the variable move downward and here both of the variable move upward. So there is a positive relationship. What is negative relationship? Negative relationship is when one variable move in one direction and the other variable move in the other direction. If one variable increase and the other variable decrease, this is a negative relationship. So correlation tells us about that what is the relationship between variable. It is either positive or it is either negative. The second thing is the strength of the relationship, that how much strong is the relationship. Zero mean no relationship. There is zero relationship between variable. And plus 1 mean there is perfect positive correlation. Negative 1 mean there is perfect negative correlation between variable. The strength of the correlation, the strength of the relationship can be identified through correlation coefficient, through the value of the correlation coefficient. And the range of the value of correlation coefficient is from plus 1 to minus 1. 0 mean no relationship, whereas 1 mean perfect positive relationship. And if the correlation coefficient value is greater than 0 but less than plus 1, like 0.1, 0.2, 0.3, 0.5, 0.9, it is known as partial positive relationship. However, if the coefficient of correlation is less than minus 1, however it is greater than minus 1 and less than 0, it is known as partial negative correlation. So this region is from minus 1 to 0. This region is partial negative relationship. 0 mean partial positive, 0 mean no relationship between variable, minus 1 mean perfect negative relationship, and this region greater than 0 and less than plus 1, this is partial positive relationship. Plus 1 mean there is perfect positive relationship. One thing we should keep in mind that correlation do not tell anything about the cause and effect relationship. Mean that which variable is independent variable and which variable is dependent variable. Independent variable mean this is independent variable is causing the change and dependent variable is affecting. So it is the regression. Regression tells us about the cause and effect relationship, Regression tells us about which variable is independent variable and which variable is dependent variable. Correlation do not tell anything about the cause and effect relationship. It only tells us about two things. What is the relationship between two variables? It is positive or it is negative. The plus and minus sign with correlation coefficient indicates the direction. For example, let's suppose that if the value of correlation coefficient is plus 0.8, it means that this 0.8 is the strength of relationship. Okay, the strength of the relationship is 80% between two variables, and this plus NT indicates that there is a positive, so it is a positive partial correlation. If the correlation coefficient value is plus 1, it means that there is a perfect positive relationship. The plus and minus indicate the relationship between variable, whether it is positive or negative. The correlation coefficient value indicate the strength of the relationship between two variables. Graphically, it looks like this. In the x-axis, the x variable is on the x-axis, y variable is on the y-axis. Perfect positive correlation. If the correlation coefficient, which is denoted by R, is equal to plus 1, then there is upward, this graph is upward, the line is upward. The upward line shows that there is a positive relationship between two variables, and if the relationship is perfect positive, all the lines, all the points will lie on the straight line. This indicates if all the points lie on the straight line, it indicates that, and if the direction is upward, this is upward movement, there is upward movement, so it indicates that it is a perfect positive relationship between x and y. Similarly, here the line is downward. The line is downward, which indicates that there is a negative correlation, and all the points lie on the straight line, which indicates that it is a perfect relationship. But the graph is downward, it means that there is a negative relationship between two variables. If the points are downwards, so the line will also be downward, and it indicates the negative relationship. If the points are upwards, then it indicates that there is a positive relationship. In this graph, the points are in upward direction, which means that there is a positive relationship, but all the points do not lie on the straight line. Some points are above the line and some points are below the line, so it indicates that there is a positive relationship, but the relationship is not perfect. It is a partial positive relationship. Partial positive means that it is less than 1 and it is greater than 0. If we look to this graph, the graph is neither upward nor downward. It tells us nothing about the upward movement or downward movement of the data. So there is no correlation between variables, because if there were relationship between variables, then there would be upward movement of the data or downward movement of the data. But there is no trend, neither upward nor downward. So it means that there is no relationship between two variables. So the relationship between variable can be no relationship, perfect positive relationship, perfect negative relationship, partial positive relationship, and partial negative relationship. We will explain all this example through an Excel working. Suppose that there are two variables, one is advertising and one is sale. When advertising increase, when a company increase its advertising, its sale also increase. If we look to this data, there is a constant change of 10,000 in the advertising, and in the sale there is also a constant change of 500,000 in the sales value. 500,000, 10,000, 15, 20, 25. Similarly 10,000, 20, 30, 40 and 50. if we draw the correlation through the graph, first of all we will select both of these two variables, and then we will click on insert, and insert we will click on the scatter graph, scatter diagram, and here we can click on any of these graphs. So I am clicking on this graph. What it indicates? It indicates that due to increase in advertising, the value of sales also increases. So the graph is upward. There is upward movement in the data, and all the data points, when the advertising was 10,000, the sales was 500,000. When the advertising was 20,000, the sale was 10,000. When the advertising was 30,000, the sale was 15,000. So the graph is upward moving. It means that there is a relationship, and the relationship is perfect positive. So what is perfect positive relationship? Perfect positive relationship is that when there is a proportionate change between two variables. What is proportionate change? In proportionate change, the slope is constant. So what is actually slope? Slope means when there is a change in the x-axis, the y-axis also change. So this is a slope. The value of x-axis change from 10,000 to 20,000. Similarly, the value of sales changes from 500,000 to 10,000. So this is the slope. This indicates the slope. Rise or run. Rise mean horizontal axis, and run mean vertical axis. So if we look to this point, when there is a change in the advertising, when the advertising increase from 20,000 to 30,000, the sales also increase from 10,000 to 15,000. This is a slope. The formula of the slope is rise over run. Rise mean vertical axis, and run mean horizontal axis. It can be denoted by rise is equal to y2 minus y1, mean 100,000 minus 25,000. This is y2, this is y1. If this is y2, this will be y1. If this is y2, this will be y1. If this is y2, this will be y1. So we can calculate the slope of the line by this formula. Slope there will be no value in the first row, and in the second equal rise over run, y2 minus y1. So this is y2 minus y1, bracket close, bracket, divided by x2 minus this is x1, equal, the slope is 50. If we drag it down, the slope is 50. So the slope is constant. When the slope is constant, we can say that there is a proportionate change between variables, and it means there is a perfect positive relationship. Whenever the x changes, it means that whenever if the advertising increase by 1 rupee, the sale will increase by 50 rupees, and it remain same for every, the slope is constant for all value of y1 minus y2 divided by y2 minus y1. This is the slope. How we have calculated this? This minus this divided by this minus this. How we calculated the second the slope of this value, this minus this divided by this minus this. From the graph we can calculate like this: 20,000 minus 10,000. This is the this is run, and this is rise. 10,000 minus 5,000. So rise is 10,000 minus 5,000 divided by 20,000 minus 10,000. Similarly, if we calculate the slope here, how we will calculate 25,000 minus 20,000, because the value on this point for y-axis is 25,000 minus 20,000, and here 50 divided by 50,000 minus 40,000. The slope is 50. We can also calculate this slope through the Excel formula equal slope function. The slope function says that first indicate the y variable. So this is the y variable, and comma, and then indicate the x variable. This is the x. Click enter. This is the slope. So the slope is constant. When the slope is constant, it means that if the slope is constant, it means that there is a proportionate positive relationship between variables. Similarly, if we look to the second example, here the slope is not constant. 10,000, 20,000, 30,000, 40,000, 50,000. But if the sale was 10,000, the advertising was 10,000, the sale was 500,000. When the advertising increased by 100% from 10,000 to 20,000, the sale only increased by from 500,000 to 800,000. So if we calculate the slope here, how we will calculate equal? First we are going to draw it on the graph. So we will select these and we will go to insert. Here in the scatter graph, and in the scatter graph we will click on this. So the points, all the points do not lie on the straight line. If this were the straight line, the direction of the straight line would be like this. This would be the straight line. So all of the points do not lie on the straight line like above. There is upward and downward movement. There is upward movement, then upward, then slightly upward, then there was a steep upward movement. So the straight line would be from this point to straight to this point. So the line is not straight, but there is upward movement. So we can say that the direction is positive, but the strength is not 1. The strength of the relationship is not proportionate. There is a partial positive relationship between two variables. If we calculate the slope of these variables, it will not be constant. Like if we apply the formula slope, rise over run, rise sale minus first value, bracket close, start bracket, then rise y2 minus y1 divided by x2 minus x1. This is x2 minus x1. Put the brackets, click enter. This is 30. For this value the slope is 30, and for the next value there is 40. The slope is 30 for this value. For this value the slope is 30, and for this value the slope is 40. So the slope is changing constantly: 30, 40, 30, 40. So this is not a proportionate change. In proportionate change the slope is always constant, and if we draw it on the graph, there will be a straight upward movement in the data. This is upward, but it is not straight. It is not proportionate because the slope is not constant. In the first figure the slope was constant, therefore it shows that there is perfect positive relationship between variables, and this shows that there is A positive relationship between variable but not perfect. Partial positive relationship between variable. Now one of the another most important thing is that why we report correlation table in thesis or in a research paper. Why? There is only one answer. Just to show that there is no problem of multicollinearity in our model. This is the main purpose. We only show the correlation table in the thesis or in the research paper just to show that our model is free from multicollinearity. Our model is free from the problem of multicollinearity. We do not show the correlation table just to show everyone that there is positive or there is negative relationship. The main purpose is that our model is free from multicollinearity. So what is multicollinearity? Multicollinearity, it is a strong relationship between independent variables. If there is a strong relationship more than 80%, either positive or either negative, if the strength of the relationship is above 40%, then there are chances of multicollinearity. If the strength of the relationship between independent variables are more than 80% or 0.80, then there are chances of problem of multicollinearity. So what is actually the problem? How the problem arises? What actually arises the problem? If the relationship between independent variable is more than 80%, so what is the problem? The problem, we can understand the problem from this model. And lecture number 1, we have discussed a model, job satisfaction and organizational justice. These are the 4 variable, independent variable: distributive justice, procedural justice, informational justice and interactive justice. These are the independent variable, and we say that if there is justice in the organization, people will be satisfied from their job satisfaction. So it means multicollinearity says that there should be no strong relationship between these variables. These are the independent variable, this is the dependent variable. There should be no strong relationship between these two variables. Because we are interested to identify, to know the impact of distributive justice on job satisfaction individually. Similarly, we want to know the impact of procedural justice on distributive justice. Similarly, informational justice or interactive justice on distributive justice. Informational justice on job satisfaction. So if there is a strong relationship between these two variables, let's say these two variables, there is a strong relationship, more than 80% relationship between distributive justice and procedural justice. So if this variable increases, this variable will also increases, and we want to identify the impact of this on job satisfaction. So if this variable increase and we want to identify its impact on job satisfaction, the procedural justice also increases because there is 80% relationship. If this variable move, the procedural justice will also move. Then we cannot distinguish that whether the job satisfaction is affected because of distributive justice or because of procedural justice. Because these two variables move together, we cannot identify separately the impact of distributive justice and procedural justice. So it is a problem. It will create a problem. So I have mentioned this model. Job satisfaction is a function of these variables. So what is actually a model? Model is nothing, but it is just a mathematical form of your topic, your research questions. Like our research question in this case is impact of organizational justice on job satisfaction. Impact of these two variables, which these 4 variables, which represent organizational justice. So this was a theoretical question, that what is the impact of organizational justice on job satisfaction. But we write that question in a mathematical form, which is represented by equality, that job satisfaction is equal to a function. Job satisfaction is based on these four variables. It is the mathematical form of what is the impact of organizational justice on job satisfaction. The most simple, this is the most simple form, most simple model. We can also write this model in this form. Job satisfaction is a function of these four variables. It is a mathematical model, and we can also write this the research question in this form. It is a pure econometric model. Whether the model is this or this or this, or we can say what is the impact of what is the impact of organizational justice on job satisfaction, or we can say okay, these are the four dimensions that influence the organizational justice. Okay, organizational justice is based on these four variables. It is same like we are writing it in a mathematical model. So this is the simplest form, this is the mathematical form, and this is the econometric model. When there is a multicollinearity in the model, the regression results are affected. It has consequences on the regression results. What are consequences of the multicollinearity on a regression model? First, in the presence of multicollinearity, the standard error of the coefficient of independent variable increases. An increase in the standard error will lead to decrease the t-statistics. If the t-statistics decreases, it will increase the p-value, probability value of the independent variable. It means that a significant variable will become insignificant. So most of the independent variable will be highly insignificant, but even then the R square will be very high, which is very contradictory, because if the most of your independent variable will be insignificant, then the model should be insignificant, then the overall model should also be insignificant, and the R square value, adjusted R square value or R square value, should be very low. But in the case of multicollinearity, the most of independent variable will be insignificant, but even though your R square will be very high, so the results will be spurious. The results will be not clear. You cannot make forecasting decision on the basis of these results, because these results are incorrect results. Now the last step is that we are going to practice is on the SPSS file. This is the SPSS file which we have developed in lecture number 1, and we have entered its data in the SPSS, and the title of the research topic is job satisfaction is a factor of distributive justice, procedural justice, informational justice, and interactive justice. So the first thing is that we will calculate the average value of these variables. There are 5 questions in the job 6 questions in the job satisfaction. So first of all, we will calculate the average value of all of these 5 variables. We will go to transform, compute variable, and first we will in the target variable we will write the name JS mean average value, mean value of the job satisfaction. So in the functional group we will click on statistical, then we will click on mean, and then we will shift all these questions one by one. Double click on JS1 and remove the question marks, then question 2 JS2 comma JS3 comma JS4 comma JS5 comma JS6, and then OK. Execute. The average, the mean value, this is the mean value of job satisfaction. There were 6 questions in the job satisfaction, so this is the mean value for the job satisfaction. We will also calculate for the rest of the variable the mean value for the rest of the variable. The second variable is distributive justice, so change the target variable distributive justice, and also remove the questions of job satisfaction and bring the questions of distributive justice. Distributive justice 1, comma 2, comma distributive justice 3, comma dj4, comma dj5, and okay. Then calculate mean value for the next variable, and after distributive justice the next variable is procedural justice, so change the name of the target variable pj. Also bring all the question of the procedural justice pj, double click on the pj1, comma pj2, comma pj3, comma pj4, comma pj5, comma pj6, and then click on OK. Procedural justice. Next variable transform compute. Next variable is after procedural justice interactive justice ij. Remove the questions of the procedural justice and bring question of interactive justice ij1, comma ij2, comma ij3, comma ij4, comma ij5, comma ij6, comma ij7, comma ij8, ij9. Click on OK. Now we are left with only one variable, that is informational justice. Write INJ informational justice and remove the question of interactive justice INJ1, comma INJ2, comma INJ3, comma INJ4, comma INJ5, comma. Click on OK. All of the five variable which represent the mean value of the variable. This column indicate the mean value of job satisfaction. This indicate the mean value of distributive justice. This indicate the mean value of procedural justice. This indicate the mean value of all of the question of interactive justice. This column indicate the mean value of all of the questions of the informational justice. For correlation analysis and further for regression analysis, we need the mean values. We do not need the single individual question. We will run all of the rest of the analysis on the mean value. So now we are going to calculate to estimate the regression. We will click on analyze, then correlate, then bicorrelate, and then we will shift all of the variable. I am shifting all of the variable including the dependent variable. However, there is no need to shift the dependent variable to the variable box because we are just interested to identify the relationship between independent variable. But just as a working, I am shifting it to the variable box. Then click on OK. This is the correlation table. This is the correlation table. In the correlation table there are three things. One is the coefficient, the Pearson correlation. These are the coefficient value. Then this is the significant level and the n shows the number of observation. We can if you want to put or report the correlation table in the thesis, we will not report this correlation table in this form. we will report this in our thesis or research paper in APS style, which is like this. This is the correlation because all of the value which were below the diagonal were same as all of the value which are above the diagonal. Diagonal means this one. So we have removed all of the values which were below the diagonals. So here 0.38 mean the strength of the relation, and there is a positive sign. It means that there is a positive relationship between distributive justice and job satisfaction. However, we are interested in the relationship between independent variable. Just we will check that is there any relationship between two variable whose strength is more than 80%. So there is 0.40, 0.36, 0.35, 0.68, 0.50, 50%, 0.56, 60%, and 0.54, 50%. So the correlation table shows that there is no strong relationship more than 80% are above 80%. 80% are above 80%. So it means that our model is free from the problem of multicollinearity. This is the first check. The correlation table is the first check for multicollinearity, and then later on we can also check the problem of multicollinearity through variance inflation factor. But this is the first test by which we came to know that there is no problem. If there exists more than 80%, then we will go to check the variance inflation factor. But now we have no need to check or go for the variance inflation factor, because all of the correlation table shows that the relationship between all of the independent variable is less than 80%. That's all from my side about correlation and multicollinearity. Thank you very much.